What up, pre-calculus students? Let's do this. Start off with some trig functions. Not going to use a calculator for it. Sine of pi over 6. Let's get our triangle out. Pi over 6, we know 180 degrees is pi. Divided by 6, pi over 6 has got to be 30 degrees. So I got a 30-degree reference angle right there. Sine is opposite over hypotenuse. The hypotenuse is always 1. Here, in my 30, 60, 90, the opposite's the short side, 1/2. Pi over 3, take pi divided by 3. Take 180 divided by 3, you get 60. So same quadrant, first quadrant, but 60-degree angle. Cosine's the adjacent, the horizontal, the x distance. In this case, it's also 1/2. Secant's the reciprocal of cosine, so we got to take cosine and flip it. Here's my pi over 6 triangle. The cosine value is the adjacent value, the root 3 over 2. So I take root 3 over 2, I flip it, I get 2 over root 3. We don't want to leave our answers like that, so we'll rationalize, multiply the top and bottom by root 3. We get 2 root 3 over 3. 9 pi over 4. Where's that? I know where 8 pi over 4 is. It's 2 pi. Add a pi over 4. So I'm going to go all the way around my circle, then add 45 more degrees because adding is counterclockwise. Side lengths are both positive because we're in the first quadrant. Cosecant's the flip of sine. Sine is the opposite over the hypotenuse. It's the vertical side length. So take the sine value and flip it. So the sine value is root 2 over 2. Flip that. 2 over root 2. You can either rationalize or simplify, and you just get root 2. Cotangent negative pi over 3. So 60 degrees, but going in the negative direction puts you right here. So there's 60 degrees. It's important to realize you're going right and down. So right on the x-axis, positive side length, down, negative side length. Cotangent is the reciprocal of tangent. You could find tangent and then flip it. Or you could just know that tangents in SOHCAHTOA, opposite over adjacent. Opposite over adjacent. Cotangent's got to be adjacent over opposite. So I'm going to do that. I'm going to do adjacent, which is the 1/2, over opposite. Keep the top, flip the bottom. The 2's cancel, or this is 2 over 2 root 3, negative. It's negative 1 over root 3, which we can rationalize, multiply the top and bottom by root 3. You get root 3 over 3, but it's negative. Okay? We should have practiced lots and lots of those, but a lot of the questions I worry about are the questions from the past lessons, trig questions. So here we go. We have some triangles, 12 something, 20. Trying to find the sine of x. Sine of x would be opposite side length over the hypotenuse. I always like to circle the hypotenuse rather than put an arrow, or else people think it's the adjacent. The adjacent side would be 12. So opposite over hypotenuse. Problem is I don't know this side length. Well, we can use our friend the Pythagorean Theorem. A squared plus b squared. I'll call this b. Equals 20 squared. You'll be able to use your calculator on your test. There's like half of the test is calculator, half the test is no calculator. My calculator's not working. I figured this out before. Oh, there it is. All right, good. So I'll do 20 squared minus 12 squared. Square root that. Nice, 16. So sine opposite over hypotenuse. Can simplify that, divide the top and bottom by 4, 4 over 5. Tangent of z, here's z, here's the hypotenuse. This would be opposite, this would be adjacent to z. So we got to find this. I'll call this b as well. Again, use the Pythagorean theorem. A squared plus b squared equals c squared. C squared always is the hypotenuse. So use our calculator. 34 squared minus 16 squared. And then we'll square root that. Looks like it's going to be 30, right? Cool. So opposite over adjacent. Let's see, divide that by 2, 8/15. Simplified. Cosine x. Here's the adjacent. Here's the hypotenuse. I don't know what the hypotenuse is, so I got to find it. A squared plus b squared equals c squared. Making sure you have the Pythagorean theorem set up correctly. I think this is going to be 25. Yep. 15. So adjacent over hypotenuse. Divide the top and bottom by 3 4/5. Express 3 pi over 5 radians in degrees. All right, well, I have 3 pi over 5 radians. How's that going to change to degrees? Well, I like to think of this as like a chemistry conversion type thing where it's like I want to cross off the radians and leave degrees. I know that there are pi radians in 180 degrees. So I can multiply by this, which is like kind of an equivalence of 1. It allows us to cross off the rads. It allows us to take that pi and get rid of it. Now I just need to do 180 divided by 5 times 3. You'll have a calculator to do this. You get 108 degrees. 48 degrees in radians, same deal. We want to write it as a reduced fraction in terms of pi. Okay, so 48 degrees. You can use this symbol. Multiply that by, I want to cancel the degrees. So 180 needs to be in the bottom, so those degrees cancel. That's equivalent to pi radians. So the degrees cancel. I have 48 over 180 pi. You can put the pi in the numerator next to it. And I want to take that and simplify it as a fraction. The ways you guys know how to do it is to use alpha F1, and usually they just automatically reduce this fraction for you. If you put it in fraction, they'll output it in fractions. Or if you just divide the two numbers, you'll get a decimal, but then you'll turn it into a fraction, math error. So 4 over 15 pi, or 4 pi over 15. All right, find the missing side length x. This is where we can use our calculator, trig function, the correct trig function of my angle to give me my ratio, and then I'll solve for x. So I get this 46-degree angle. I have the opposite side, and I have the hypotenuse. Opposites and hypotenuse. In SOHCAHTOA, we got sine. So SOHCAHTOA. Sine of 46 degrees equals 8 over x. Now I'm just going to solve for x right now. How do you do that? Got to get x up. You'll have to divide by sine 46. I think a lot of us actually kind of struggle with the solving for x in a denominator. You could also like cross multiply. If you put the sine 46 over 1, you could flip both sides, then multiply by 8, whatever. You get this. If you didn't have a calculator, I'd expect you to just leave this. If you did have a calculator, here's one thing you have to worry about. Got to change your mode from radians to degrees. Okay, because if I type in sine 46 and I'm in radian mode, it's going to take 46 and, it'll think of it as an angle, not in the first quadrant, but like, as like a multiple of pi. It'll be around the circle a bunch of times. So anyways, make sure you're in degree mode. If you're using degrees, 8 divided by the sine of 46 degrees gives us 11.121. Round to 3 decimal places. Okay, so 11.121. In this situation, this is the hypotenuse. There's my angle, 23 degrees. I have the opposite side length and the adjacent side length. Which trig function should I use? TOA, tangent. The tangent of my angle would equal the opposite over adjacent. Now, x is in the numerator, so to solve, I just multiply both sides by 6. Again, make sure your calculator's in degree mode. 6 tan 23 in degree 2.546 or 547 if you round. All right. Duncan's flying a kite. The length of the kite string is 30 feet when the kite is 10 feet above the ground. Eloise is standing directly below the kite. Find the distance between Duncan and Eloise. All right, so here's Duncan flying a kite. Here's the kite. Kite is on a string that's 30 feet long. Kite is 10 feet off the ground. Eloise is standing right below the kite. What's this distance here? You don't have to use trigonometry. You can use the Pythagorean theorem here. We could call this, I don't know, A. I don't know. A squared, we have a right triangle, so that's why we can use the Pythagorean theorem. A squared plus B squared equals C squared. A squared equals 900 minus 100, so 800. So A is root 800. They ask you to round to 3 decimal places, so we don't want to simplify that. We could simplify that by trying to find the biggest perfect square that goes into 800, but just make sure I got it right. 30 squared minus 10 squared. You go, square root of 800. 28.284. Ship is sailing due east. Captain sights a buoy ahead of the ship at an angle of 25 degrees to the right of the path of the ship's motion. So, to the right of the path of the ship's motion would be like that. So we're saying that 25 degrees, that's where I've got. By radar, she determines that the buoy, B, is 9 miles from the ship. Draw a diagram, indicate the buoy. There we go. Assuming the ship doesn't change direction and the buoy stays stationary, calculate the closest the ship will come to the buoy. Well, we could see that like if you have a right triangle, the closest you would be is if you were right here at this location, because that would be like perpendicular, and then any other spot on this line, we would have this angular distance, which would be longer than this straight distance. So we want to find this side length right here. Okay? Now, what is 9? 9 is the hypotenuse. What is this shortest distance? It's the opposite side. You should be thinking of using SOHCAHTOA again and using the sine of 25 degrees. That would equal my missing, I'll call this distance D, or, if you like to use the Pythagorean theorem, A squared, B squared, this is C squared, so maybe like A. So, or let's just go with x, as an unknown. You guys like using x. X over 9, so sine opposite over hypotenuse. You solve for x, multiply both sides by 9. You're allowed to use your calculator on this one. 9 sine 25 degrees. 3.80, we'll call that 4. How far must the ship travel to reach this closest point? Well, that's this distance. Okay, how much further do you have to travel to get to that point? Well, now that you have this side length, 3.804 dot dot dot, we can find this x distance two different ways. Okay, let's find it two different ways. You can use the fact that you already know this vertical distance and you know the hypotenuse, and you can use the Pythagorean theorem. So we have the 3.804 number, the entire number squared, plus my new x that I'm trying to find. Let's call it let's call this d or something. That way we don't get confused. And that equals 9 squared. Okay, that's one way. Now, if you're going to use this 3.804, don't have it rounded. Okay, we want to use the full number so that we get an answer that's more accurate. If you use rounded numbers to get different answers, those different answers are going to be less and less accurate. So I get d one way using the Pythagorean theorem and my other found side length, 1.5677. So I'll write it as 1.57. Or you could say, oh, d is the adjacent side, 9 is the hypotenuse. Cosine 25 equals d over 9. Multiply both sides by 9, and here's your other way to find d, which will be 8.157. 9 cosine 25, 8.1577. See, you get the same answer two different ways. It's up to you which way you want to do it. Scott is looking at the top of a cell tower. So Scott's on the top of a cell tower. Here's my cell tower. Here's Scott. Angle of elevation, 25 degrees. So like if we go out to the horizon and we go up 25 degrees, that's what Scott's doing, looking at. Oh, wait. No, Scott's not at the top of the cell tower. Scott is looking at the top of a cell tower at an angle of 25 degrees, like that. Scott is standing 150 feet from the base of the tower, so this is 150. How tall is the tower? What's that y distance? All right, this is the hypotenuse. There's y, it's opposite. There's 150, it's adjacent. We're going to use trigonometry again. Tangent of my angle equals opposite over adjacent. I'll solve for y by multiplying both sides by 150. 150 tangent 25. 69.646 would be this length. 69.946. This is interesting. Okay. We're told that theta is obtuse. Okay, so we're past 90 degrees. We're told that the sine of theta is 3/5. Now, you got to remember, Very important theorem. Sine of a obtuse angle, anything past 90 degrees, is the same as the sine of the reference angle. Okay. Now, I'm thinking we need to be in the second quadrant rather than the third or the fourth, which are both obtuse angles if we keep going. Because sine giving us a positive ratio, we need to be going up on the y-axis. We need this to be opposite and this to be the hypotenuse. So I need that to be 3 and that to be 5. Now, what would be the tangent of this angle? Well, boom, opposite adjacent. I'll show you a different way to find this too. So I need to find this side length, this x distance. I can use the Pythagorean theorem or just know that it's a 3, 4, 5 right triangle. 3 squared plus x squared equals 5 squared. X squared equals 25 minus 9, which is 16. X is 4. That means the tangent of theta is opposite over adjacent 3/4. Watch how I can find this answer in a different way. Maybe. Let's see. Let's say you have your calculator. I don't know if you have your calculator or not for this question. But watch how I can find the angle measurement, theta, in degrees. I can take the sine inverse of both sides and find what theta is. So let's take the sine inverse of 3/5. Oh, I made a mistake. I said x is 4, right? I don't like that. X is -4. Why do I say it's -4? Because we're going to the left because we have an obtuse angle. It's like when you take the square root. I like, with triangles, usually we're used to having just positive side lengths, but direction matters now. So I'd say actually like you could have a positive or a -4 as this answer. And in this case, since I'm in the second quadrant, I'm going to say x is -4. So that means this ratio is -3/4. Now let's see if we get that -3/4. I don't think so. I think we're going to be stuck in the first quadrant here, this first quadrant. So if I find the tangent of that angle, it's going to give me 3/4, but it'll be positive. Yeah, there's that positive 3/4. But I want it to be -3/4 because I want the angle to be obtuse. It's almost like I need to, take 180, subtract that, and don't do it this way. This just is a little bit more complicated than you guys need it to be. This would be the alternate way of getting -3/4. This is your calculator doing its best job to approximate values, which is why you don't get like -0.75 flat, but it's very close to being -0.75. So anyways, don't do it this way. Instead, let's use an XY axis, kind of think about our situation, make sure we pay attention to directions. When is cotangent positive? Now, there's an acronym to help you remember this, but let's try to figure it out somewhere, some other way. So cotangent is adjacent over opposite. So the question is, when is adjacent over opposite going to be positive? Well, there's two ways to get an adjacent over an opposite to be positive with triangles. It's if you have a positive adjacent and a positive opposite. So that's when your angle's in the first quadrant. If your signs are different, then when you divide the two, like here, adjacent's negative, opposite is still positive. Here, positive, positive. Here, adjacent's negative, but opposite's negative. Here, adjacent's positive, opposite is negative. So we need the signs to be the same. So this is the first quadrant and the third quadrant. Now, another way to remember this, and we're going to use this in the future, is Astc. This is telling me which trig functions are positive in which quadrants. Tangent and their reciprocals. Tangent and cotangent are positive here. All of the trig functions are positive here. Let me show you how you could do either way with sine. Here, sine is negative. Less than 0 means negative. That means the opposite needs to be negative because hypotenuse is always positive. So this is negative. This is negative. We're in the third and the fourth quadrants. So using like just 4 random triangles placed down and understanding side lengths, that's one way to do it. The other way is to use ASTC. I don't know what my cursor just worked. And you can see sine is positive in the first and the second quadrants. So that means it'd be negative in the third and the fourth. So either you see negative opposites here in the third and fourth, or you say, okay, sine is negative in the third and fourth because just tangent and cosine and they're reciprocals. Tangent's negative and cosine's negative. All right, well, tangent's negative here. Cosine's positive here. Tangent's negative here. When is tangent both negative and cosine negative? Like you need to be moving left and opposite over adjacent needs to be negative. That's only in the second quadrant. Okay, I hope you understand that. Either using triangles or ASTC. Is it possible for an angle to satisfy both of the following equations? Sine of theta equals √3/2, cosine theta equals √2/2. Well, it's like the only time I have an opposite side length that is √3/2 is if you have a pi/3. It's actually pi/3 or 2 pi/3, right? Because this is from a 30, 60, 90 triangle. But the only time you see √2/2 is from the 45, 45, 90 triangles. So if you think about, can you have an angle that gives you a sine that's that and a cosine that's that? No, because you're talking about 2 different triangles. This happens at the pi/4s. It's actually 7 pi/4 in the fourth quadrant where it's positive. So the answer is just no. And the explanation would be like, you need 2 different triangles. To give you √3/2 or √2/2. All right, we're back in unit circle land. 5 pi/6, 1 pi/6 less than 6 pi/6, 30 degrees. Cosine, adjacent over hypotenuse. The hypotenuse we don't have to worry about. The adjacent is always the x distance, so that's going to be negative √3/2. Secant, 2 pi/3. Take 3 pi/3, subtract a pi/3, 60-degree reference angle, tall 30, 60, 90. Secant's the reciprocal of cosine. Find the cosine. Cosine is -1/2. Flip it, -2. Sine, negative pi/6, negative pi/6, 30 degrees, fourth quadrant. Sine is the opposite. That's the shorter side in this case, -1/2. 135 degrees, 180 minus 45. So we have a 45 reference angle going up √2/2 over negative √2/2. Cosecant is sine's flip. Sine is opposite, it's the vertical. Flip √2/2, you get 2 over √2, which is just √2. It's positive because the vertical distance is positive. If I'm at pi, here's pi. The x distance is -1. There's no y distance. Cotangent, adjacent over opposite, x over y. X is -1, y is 0. You're not allowed to divide by 0. What number times 0 gives you -1? Nothing. Tangent of 0 plus the sine of 3 pi/2. 0, here, you go to the right one, the x distance is 1. Tangent, y over x, there is no y distance, so it's 0 over 1, which is 0. 3 pi/2, going down 1, the y distance is -1. The sine, opposite's always the y distance. Y distance is -1. 0 plus -1 is -1. The terminal side of an angle passes through the point -3, -5, -1, 2, 3, -1, 2, 3, 4, 5. This is how we set this up. create a triangle. Okay, -3, -5. What's the cosine? Adjacent over hypotenuse. We got to find the hypotenuse. We got to use our friend Pythagorean Theorem. I know -3 squared is the same as 3 squared. So I'm just going to do 3 squared plus 5 squared equals. This is 9 plus 25, which is 34. So C's got to be the square root of 34. I'm just going to leave it like that. Cosine adjacent over hypotenuse. Rationalize, -3 root 34 over 34. I just want to make sure, like -3, -5. Yeah, that's right. 3 squared plus 5 squared are our two legs, 34. All right, cool. And then cosecant. It's easy to do this, not by getting the sine value then flipping, but to think about sine being opposite over hypotenuse. The flip of opposite over hypotenuse is hypotenuse over opposite. Okay? We got to remember that secant and cosecant are flipped. Hypotenuse over opposite, hypotenuse over opposite. So I got root 34. The hypotenuse is always positive. We never label the hypotenuse. We think of it as a distance away from the origin. So we don't worry about left, right, up, and down because it's always like diagonal coming from the origin. We always consider that positive. Opposite, -5. What I'd want you to do is understand that 120 degrees is 60 degrees away from the x-axis. Here's the rotation notation, the angle measurement, the reference angle. 344 is what? Plus 6 is 350, so plus 16. So 16 degrees away from 360. Make this a little bit crazier. There you go. But going all the way around 344 degrees gives us there. -5 pi over 3. This is a little tricky. I would like to say it's -6 pi over 3, but then I have to add a pi over 3. So -6 pi over 3 goes around this way. This is all the way to -6 pi over 3. But then if I add a pi over 3, I don't make it all the way around to 2 pi. I stop right here, being 60 degrees away from the x-axis. This would be -5 pi over 3 radians that I've traveled. 17 pi over 8. I don't want to convert this. I know where 16 pi over 8 is, right? It's just 2 pi. And then I add a pi over 8. What's going to be a pi over 8? It's going to be half of pi over 4, right? So if pi over 4 is 45 degrees, divide that by 2, pi over 8 becomes 22.5 degrees. I can figure this out without a calculator. I want to go to 2 pi, so I want to go around my circle and then add 22.5 degrees. So go around 360 degrees, add 22.5 more degrees, and this is the location of 17 pi over 8. It is a pi over 8 more than 2 pi. So that's 360 plus 22.5. That's going to be 382.5. Watch this. If you want to convert it, multiply by 180 degrees divided by pi rads. Boom, boom. 17 divided by 8 times 180. I'll get 382.5. Boom, without a calculator. All right, couple more. This is a big help. We're told that we are in quadrant 3. We are told the cotangent is 5 halves. Okay, so We got some angle in quadrant 3. Now, cotangent, reciprocal of tangent, tangents, OA, TOA. Cotangent would be AO. So, in the third quadrant, I'm told that the adjacent is 5, the opposite is 2. So you might want to label it like this, but look at where we are. We're in the third quadrant. The only way to label this correctly is to label this as left on the x-axis and this is down. But does that make sense? It's like 5 over 2, that's positive. But watch this. Negative 5 over negative 2. That's positive. So we have to be okay with, like, in different quadrants, maybe we have signs that are like both negative. Maybe one side's positive, one side's negative, depending on the situation. Let's use the Pythagorean theorem to find the hypotenuse length. So 5 squared plus 2 squared, it's 25 plus 4, c squared. So 29 is c squared. So c is root 29. Can't really simplify that. I'm going to leave it like that, though. So I don't love the triangle. This should be coming out from the origin. But reference angle is going to work for us. Now we can do everything. Sine, opposite over hypotenuse. Negative 2 over root 29, which simplifies to be negative 2 root 29 over 29. Rationalizes to be. Cosine, adjacent over hypotenuse. Negative 5 over root 29. Rationalize that. Negative 5 root 29 over 29. Tangent, opposite over adjacent. Negative 2 over negative 5. But I would expect you to be able to be like, oh, well, that's just positive. So it's just this flipped. And that's just 2/5. Okay? Good question. This is like a similar question. These are the ones that I think students have the most problems on. Hopefully that's not the case. Secant, which is cosine flipped, is 4/3. So that means cosine's got to be 3/4. That means adjacent over hypotenuse needs to be 3 and 4. But we got a situation where sine's negative. So that means the opposite needs to be negative. Cosine's positive, sine's negative. Where are we? Here, in the fourth quadrant. Okay? Adjacent's 3, hypotenuse is 4. The opposite's going to be a negative number. Very important to pay attention to that. I didn't really find it on that first problem that we did, but now we're paying attention to it. We're good. What is that opposite length? Well, 3 squared plus, whatever that y squared is 4 squared. 16 minus 9 is 7. So y is negative root 7. Let's see, 9 plus 7, 16. All right. Reference angle is all we care about. Now we're ready to use our trig functions, SOHCAHTOA. Sine, opposite, hypotenuse. Hypotenuse is always considered positive. It's a distance from the origin. Tangent, opposite over adjacent. Cosine, adjacent over hypotenuse. It's the flip of secant, which we already told was 4/3. Coterminal angles, sweet. How do we get to coterminal angles? Well, 135, which is 45 degrees away from 180, right here. What's another angle that ends up right here? Add 360 degrees or subtract 360 degrees. You can do it with a calculator, without a calculator. We got coterminal to 495. A lot of people struggle with subtracting, but if you take 360, subtract 135, just take that number, make it negative. So this is 5, this is 5, 2, negative 225 in degrees. It's tough to add 360 and subtract 360. You know what's easier than doing that? Adding 2 pi's. Here's 3 pi over 4, 45 degrees less than 4 pi over 4. All we need to do is add 2 pi, subtract 2 pi. Add 2 pi. Wait, hold on. That's not going to be easy to do. You don't have a common denominator. So don't add 2 pi, add 8 pi's over 4. 3 pi over 4 plus 8 pi's over 4, that's easy, 11 pi over 4. Subtract 8 pi over 4. Negative 8, negative 7, negative 6, negative 5, negative 5 pi over 4. And like you can really probably figure this out without doing those calculations. You think like, how do I get here? It's like negative 4 pi over 4, add another pi over 4. 8 pi over 4, 9, 10, 11. 8 pi over 4, 12 pi over 4, 3 pi, subtract a pi over 4. Different ways to do it. Negative pi over 6, 30-degree reference angle right there. Add 2 pi, subtract 2 pi. Well, adding 2 pi is like adding 12 pi's over 6. We want to have a common denominator when we're adding fractions. Subtract 12 pi over 6. So we get 11 pi's over 6. That makes sense, like 12 pi over 6 minus a pi over 6. Or negative 13 pi over 6. Add negative 12. That's like subtracting 12. So going all the way around to negative 12 pi over 6, then subtract another pi over 6. Boom. Okay. All right. I hope this video helps us. Definitely do the other practice problems in that review folder. They'll be very similar to what you'll see on your test as well. Hopefully you're ready for this. See you Monday.